Okay, we have our computer. We can start putting in some software, but we don't have any software yet. The software we're trying to serve is empty. Basically, software is just rules. It's made from instructions that tell the computer what to do, put in very carefully. It evolves quickly, like any other technology though. At its core, it's just ones and zeros. But built on top of that are higher level languages, known as programming languages. Each programming language is written to a various degree. Some are really low level. They are practically right on top of the ones and zeros. That's assembly. Other ones are built high up on top of it, and anything you write there, anything we put into here, well, it's really separated from the ones and zeros, which can cause problems, but can make your life easier. However, every single language, or at least practically all languages, are going to need some very simple things, some very common things between them. They're going to need a way to store information. These are typically called variables. But those variables typically have a type, whether it's implied, just you know it's that type, or if it's strictly enforced. So you have types, which is kind of like our sets that we have talked about. Then you need a way to manipulate that. There needs to be rules, such as for colors, you can change red to blue, but you can't change red to 1. With numbers, you can add numbers together. That's a different rule. So you need a way to manipulate different information depending on its type. That's called operations. Another thing, depending on the programming language and the type of computer, the environment you're using, you're going to need a way to do input and output and get some of the more nitty-gritty details. That's usually different from programming language to programming language, but it's always there. Here's the thing. You only need the very basics to make a program. Most of the books I have read, such as this one about C++, they say about that much in, you can start making reasonable and respectable programs. Of course, there's a lot more because, well, there's a lot more that can fit onto this plate. There's a lot more interesting things you can do and build up. But with these basics, you can make a program. This stuff is practically our axioms though. Info, patterns, and rules. Pattern bridging. Relating these patterns together and knowing how to put stuff together. It's just our simple rules. That's what we're doing here. Remember, the first thing I started talking about was that you could have something and nothing and differences. That's all computers do at the very core. So while later on you could add classes and functions and stuff like that, and debugging tools, just this, you can make cool programs, and that's what we're going to do. And you can find this in practically every single language that you're going to come across reasonably. So there is that idea of reusability and modularity. That's a part of what makes programming powerful. You can take one program and run it as many times as you'd like. You can take one piece of a program and put that in as many different programs as you'd like. The other idea is modularity. When we're taking a program, let's say that it has to start with an orange and end with a purple, and you can put whatever else you'd like in there. Well, you can change that up. You can make it super complicated. You can make it super simple. That's going to let you be creative and create many different types of programs that run efficiently in some cases, poorly, quickly. It's all up to you. More complexity is going to come with familiarity. So you're going to have to be prolific. You're going to have to make a bunch of programs and feed them into the computer and just keep pumping stuff out. Because if you want to make good programs, you have to make a lot of programs. If you want to make games, you're going to have to make a lot of programs. If you want to make good games, you got to make a lot of games. It's simple. So let's do it.